just want to point out, every ring of the diagram is made up of these geometric pattern, this geometric pattern. So you have these two circles. They have a radius of 0.49 root 2, and a diameter of 2 times that, which is 0.96 root 2. We have an overall length of this one circle as 1.8 root 2. Again, so these are all base 12 numbers. So every circle, every one of these on this pattern is exactly the same. Circle with a line drawn directly through the center, the diameter, the positioning of all these is the same. But as the pattern grows, each of these rings of the diagram is made up of 2 circles. And the first circle is in units of 3.2 root 2. So that's defined by the radius. That's the 45-degree line, so units of square root of 2. And then the second ring is defined by adding the length of 0.5 root 2 at a 90-degree angle in the form of a squared plus b squared equals c squared. So we get this triangle. You can see it here. I hope you can see that. So each ring of the diagram is basically comprised of long, thinner and thinner triangles. So we're creating polygons. And so the first ring has 24 sides. So there's 48 little triangles. And then we do 2 times that for the next ring, and then 3 times and 4 times and so on. So you can see the progression is very natural. 1 time, 2 times, 3 times, 4 times. But what happens is the gap between those 2 rings, adding that same distance of 0.5 root 2 and then drawing a circle, the gap between those 2 circles gets narrower and narrower as the overall pattern gets larger and larger. Sort of counterintuitively, more space is formed with each. The diameter is always the same. We're always dividing it into the circumference 3 times. That's it. We're never adding more units of diameter. Our traditional model for pi is we start with the 3 and then we add on 0.1, and that length is a solid line. But now we have a discrete line that's appearing in the circumference. And so every time we do that exponential division and we add more pieces, we're not really adding more. We're just dividing the length into smaller units. And then when we place them on the circumference, we somehow get more space, although these circles are somehow being squeezed closer and closer together. So there's sort of it's an interesting phenomenon that's occurring as we grow the diagram.